Hello friends, this question is from test series number 1. Subject name is control system, topic name is frequency response analysis using Nyquist plot. It's a 2 marks problem. Question says that in the given transfer function, for a given number of encirclement made by, for a given system, the encirclement made by the Nyquist plot around point -1, 0, that we need to find it out, that what is the number of encirclement is made by the Nyquist plot. So the transfer function is s.25 upon s square s plus 1 s plus 0.5. So in this the transfer function has a 2 pole at the origin. So 2 pole at the origin, so my system is going to start from -180 degree, and we have 1 pole at the origin, 1 0 and 2 pole at high frequencies. So my transfer function is going to end up in the -270 degree. So my polar plot will be something like this. It's going to start at -180 degree and it's going to end up to the -270 degree. So now if you learn to draw the Nyquist plot, so it will just add the mirror image of the polar plot in this. Okay, and complete the Nyquist contour. Just complete the contour. So this will be my Nyquist plot. Right, this will be my Nyquist plot. We start from -180 degree ending to the -270 degree. Okay, that is the simple observation from the transfer function. We have drawn the Nyquist plot, but the point is how many encirclement around -1. So the point is which we want to find is what is the frequency, what is the value of frequency, or what is the point, what is the value of this what is the coordinate of this point, right? Because if we get the coordinate of this point, then we can say that how many encirclement, because we don't know whether this point is coming right to the -1 or left to the -1. Okay, -1 is belong to the right of this point or left to this point, right? So for the any judgment, we need to know the coordinate of this point. Let's say it is a point A. Okay, so just put the value of omega in s is equal to j omega, so it will be j omega plus 0.25 upon j omega square j omega plus 1 j omega plus 0.5. Just rationalize the transfer function, multiply with the conjugate, rationalize the transfer function, and you will get the transfer function as minus of 0.125 plus 1.25 omega square upon omega square 1 plus omega square 0.25 plus omega square plus j times omega square minus 0.125 upon omega into omega square plus 1 upon omega square plus 0.25. It's a simple rationalization. Just multiply and divide with the conjugates, then you will get the rationalized version in which the real part and imaginary part is separate. From this expression it is very much clear if you want, because what is the speciality of point A? At point A my imaginary part is 0, my y component is 0, it's in the x-axis. So if I want my j component to be 0, so from the enumerator you can say that my omega square must be equal to 0.125. My omega square must be equal to 0.125 if you want the this y axis to be equal to 0. So just put this value of omega square. So for this omega square is equal to 0.125, my imaginary axis is 0, so my a will be equal to the transfer function at omega square is equal to 0.125. Put this value here, so it will be minus of 0.125 plus 1.25 into 0.125 upon 0.125 into 1 plus 0.125 into 0.25 plus 0.125, so your 8 comes out to be 5.33, minus, of course, minus of 5.33. So coordinates of A is minus 5.33. It means that minus 1 is lying inside this circle. It means that the total encirclement of minus 1 is, you can see that 1 and 2. So total encirclement of minus 1 is 2, right? Because the encirclement is clockwise. So because the encirclement is clockwise, right, so we will say that it will be minus 2. The anti-clockwise encirclements are considered as a 1, clockwise it is minus 2. So the total encirclement will be minus 2. Thank you.